Hi there, and welcome to this lesson. In this lesson, we'll be learning formulae. Okay, we're learning about more about formulas, and under formula, we'll be learning change of subject formula. Now, change of subject formula. Now, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, change of subject formula. Now, what exactly is this about change of subject formula? So we're going to be changing the subject of a formula. Now, consider this formula. Okay, so we have this very simple formula V equals IR. So this is a formula you typically use in solving for V, where V is voltage, I is current, and R is resistance. Now, this is a very important formula when you're working with electric circuits. Okay, so you have voltage, current, and resistance, and V equals IR. So the voltage across an electric circuit is always the product, where basically you multiply the current flowing through the electric circuit and the resistance in the electric circuit. Okay, so basically you really don't need to bother too much about what this represents. You just need to know the formula is V equals IR. Now, in this formula, at the moment, V is the subject of the formula because you're going to use this formula to solve for V. V is the purpose of this formula. So if you had a question where you're required to solve for V, for the voltage in the circuit, say you're given current and resistance, basically you'd apply this formula V equals IR, and you can just substitute the values there. You have that V is, you have 2 amperes and 5 ohms. Okay, so 2 current is 2, resistance is 5, and you just multiply 2 times 5, and what you have in the end is you have 10 volts. Simple. Okay, now what if you had a situation like this? Okay, you have the voltage across an electric circuit is 12.5 volts. If the resistance in the circuit is 2.5 ohms, calculate the current through the circuit. Now, this time around, you're given voltage, you're given resistance, okay, but now you've been asked to calculate current. And we know that the formula that relates voltage to current and resistance is V equals IR. That is our formula. But at the moment, this formula is set in such a way that it solves for V because V is the subject of this formula. Now, if you were looking to solve for current I, okay, I stands for current. So if you're looking to solve for current I, you would still apply this formula, but you would have to change the subject of the formula. Okay, so you have to rearrange this formula such that it solves for I instead of V. Okay, and what you do is that you treat the formula as though it were a linear equation. Okay, when you're looking to change the subject of a formula, you work the formulas as though as though the formula was a linear equation. Okay, and you work, in this case, we're going to be working this formula as though we're trying to solve for I. Okay, so let's say we want to make I the subject of this formula. We want to get I on its own and on the left, and then everything else on the right. Okay, now at the moment we have R multiplying I, and what we do is we divide both sides by R. Okay, and when we divide both sides by R, so divide V by R, divide IR by R, you're left with I, and then you have the I equals V times R. And that's it. That's basically what we're going to be learning this lesson. So you've just changed the subject of this formula from V equals IR to I equals V over R. And now you can apply this formula to solving for your value for I, and you have your value for I as 5 amperes. So 12.5 divided by 2.5, and you have your answer as 5 amperes. Simple, straightforward. So that's basic. That's the basic idea behind changing the subject of a formula, and we'll just go ahead and do a few examples. It's really easy. So we have if y equals 2x minus 9, because that's the formula relating x and y, express x in terms of y and find x when y is 5. So we have our formula y equals 2x plus 9, and we're just going to rearrange this because at the moment y is the subject of this formula. We're going to rearrange this to make x the subject of the formula, and like I said, when you're looking to do that, you treat the formula as though it were a linear equation. Okay, and at the moment you're trying to get x on its own on the left and everything else on the right. Okay, now the first thing we have minus 9 and we just move that across. So we have 2x equals y plus 9. Okay, and then we have, at this point, you should probably guessed it, we just go ahead and divide both sides by 2. And what we have is we have x equals y plus 9 over 2. And that's it. We've just made x the subject formula. It's really, really easy, okay? It's no different from solving a linear equation, all right? When you ask to make something the subject of formula, it's like solving that a linear equation to get that thing as your result. So you want to get that thing on the left and then everything else on the right. And you just apply the difference. You move things across the equal sign, you divide both sides, you sometimes have to find the square root if you have a square involved, and etc and etc. But let's go ahead. So we have the formula x equals y plus 9 over 2, and now we can find x when y is 5 by simply substituting 5 for y in the formula. And basically what we have in the end is we have x equals 7. Simple, straightforward. Let's move on. Now, example 2. And example 2 we have, okay, now this is a very interesting one because we have a square in play here, okay? And basically this one says if y equals 4a squared, 4ax squared, make x the subject of the formula. Now, to do this, basically, we just need to solve this as though it were a linear equation and work to get x on the left and everything else on the right. Okay, now we have 4a multiplying x squared. So the first thing we do is we divide both sides by 4a. Okay, and what we have in the end is we have x squared equals y over 4a. And now we have a square. We need to get rid of that square. We quite simply find the square root of both sides. And what we have in the end is we have x equals root of y over 4a. And that's it. Very, very, very simple stuff. Okay. And final example. If 1 over u plus 1 over v equals 1 over f, make u the subject of the formula. Now, this is a very interesting one. Okay, this is a very interesting equation in optics. Okay, it's the lens equation, and it's a very, very interesting equation. And we're just going to make u the subject of formula in this case. So the first thing we're going to do is we're going to move 1 over v over to the right. So we have 1 over u equals 1 over f minus 1 over v. Okay, and then we're going to solve that. Solve 1 over f minus 1 over v. Solve that as though we're working a fraction. So we have the LCM FV, and then we divide FV by F, it gives us V. Divide FV by V, it gives you F, so you have V minus F on the top there. And if you have that 1 over U equals V minus F over FV, you would agree with me that if you just flip both sides, you have U equals FV over V minus F. And that's it. Really, really, really simple stuff. Okay, so that's basically how you change the subject of a formula. And very, very important, because basically we work with formulas all the time. Even if for example, you could be looking to find, let's say you're given the area of a circle and you're asked to find the radius. You know that the area of a circle is pi r squared. Okay, but if you're looking to find the radius of that circle, you need to rearrange that formula such that it makes radius r the subject of a formula. And if you do that, you should end up with the square root of a over pi, basically. Yeah, so go ahead now and attempt questions on the worksheet. Bye for now.